Hello, welcome to Tom's Hardware, the podcast for November the 19th. It's nearly Christmas. I thought I'd get it in now, why not?
Oh, yeah.
Yeah,
Just hit me
Sean's
with
happy
that
now.
right at the start. Damn, Les.
That's it. With me, I have Sean Tracey. He's an old friend of mine and a maker of extraordinaire is the term I will use. I know stories about Sean that will make your hair curl.
Made my hair
Great.
fall out. So, that tells you something about the stories that
Pretty
shall
much.
not be echoed on this broadcast today.
Exactly. But Sean, after that graceful intro, I'll say, do you want to tell the world about yourself?
Sure, yeah. So, hi, everyone. I'm Sean. I think this is my third time on this show now, third year in a row.
Yeah.
I like to pop in once a year with something new and exciting and interesting that I've put together. And this time, I've brought a distributed compute cluster crammed into a briefcase. Why have I brought this? Well, I'm the head of developer relations at a company called Expanso. We make a piece of software called Barrier, which makes it really easy to do what we call compute over data. That is sending off workloads to any location, any system, anywhere on the internet, anywhere on the planet of any real kind of capabilities, and executing on those devices in real time, running the device. And this was a nice thing to get started about. So that's why I've built this. That's why I do it. It's my job to help people understand what we do and why. And so we'll dive into the meat of that shortly.
Yeah, definitely. I mean, what caught my eye straight away was it's a computing cluster in a briefcase. And it's those terms are usually exclusive, aren't they? A briefcase and a computing cluster. So, I mean, why is the question to us? Why would you stick an entire computing cluster in a briefcase apart from to demonstrate the services of the company?
I mean, I get asked the question why a lot, not necessarily for this thing, but in this particular instance, we had two kind of problems that we were trying to solve recently. The first is that when you're trying to get your name and your wares out in the world, you go to a lot of conferences. And, everyone likes to think that they have the best, shiniest, most awesome and interestingest thing in the world. But there are 1,000 other people in a conference who have the exact same opinion about their stuff. So we were thinking about ways to stand out from the crowd a little bit. What could we bring that was unique and interesting and would capture people's attention in a way that a screen or a banner or just saying, hey, when people walk past you, which gets tired. I've been on the other side of that after half an hour. So we thought, what were the kind of, what could we do in a reasonable space of time that would excite and interest people and they can have a good conversation with us? That was the first problem we were trying to solve. The second one was we do distributed computing. So everything that we build and run and talk about involves a great deal of cloud infrastructure, edge infrastructure, parallelized computing. There are a lot of concepts and topics in there, which if you work in that space, second nature. But for everyone else, it's something that you can get together in a real short space of time. But when you're on a conference floor, you've got maybe 30 seconds max to really get people up to speed before you can have the conversation you want to have, which is how they can use this stuff to solve their problems. So having something with us that we could point to and say, okay, these are the parts, here's how they work together, here's how you can use that, and then show them that it actually does work. That was really compelling as well. So I read a lot of history and particularly the history of technology. And one of the things I knew about was the nuclear football. So for the audience members at home who don't know what the nuclear football is, it is a mobile command center that the American president always carries with him or her to retaliate if someone launches a nuclear strike against them, which is a terrifying thing to think about. But as far as a piece of technology goes, it's very interesting and impressive and a nice and cool form factor. So I went to my boss. I was like, hey, I know we're thinking about how we can stand out at this conference on Monday. This is TechCrunch Disrupt that we were just at. This was the Thursday that I had the idea, and we had the Monday before it was had to happen, and there was a big old flight in the middle of that. So he said, okay, how do you feel about me making a nuclear football but for Expanso? And Dave went, "Yep, do it." So began my 48-hour odyssey of going all over the UK, over to the West Coast, all around the Bay Area, and then building this thing in a hotel room. You would not believe the looks I got from the hotel staff when I rocked up with that trolley filled with foam boards and a bunch of tools from Lowe's. So yeah, that was the kind of build right there. So what do you need to put a compute cluster into a briefcase? You need a bunch of computers. And, Les, you're a maker. I'm a maker. When we're thinking about making something, what do we make things with? 9 times out of 10, it's probably Raspberry Pi. Powerful Linux computer. The 4s and the 5s particularly have quite a lot of power in them. Quad-core ARM chipsets with, a decent amount of RAM. So I set about getting some of those. I went to the Raspberry Pi store in Cambridge and just nonchalantly picked up a bunch of them, walked out the store without explaining what I was going to do with them, because I don't think they'd have believed me if I tried to explain. And then flew to America for the second time in my life, which was, it's a long flight, and you can't really try and build things on a plane. People get nervous, so you have to just kind of sit there and wait. When I got to the Bay Area, I still didn't have a briefcase. I still didn't have the power adapters. I still didn't have anything to kind of hold it all together, the tools to build these things. And I had, at this point, I think 24 hours to put it together. So lots of mad running around the Bay Area. I went to a Best Buy. I learned what Best Buy was, and then I went to one and bought a travel screen, which you can see there. So travel screens are great for people that aren't familiar with them. I wasn't familiar with them. It is essentially a laptop screen without the laptop. So it's great for a second screen. It's slightly bigger, incredibly lightweight, really easy to affix to the case, to the lid. And then just put it in there with a bunch of foam. I was up at 4 a.m. in the middle of the hotel room with a hacksaw and standing, carving this thing out, trying not to make too much noise. No one complained. No one said anything. I cleaned the room after, so it was fine. But that was one of the... That was an experience that one doesn't expect to have, And again, what was really nice about it was super effective. It had the impact we wanted it to have, which is people would be walking down the aisles and they would see this thing and they would go, "Well, what's that then?" Because it's not like anything else you'd ever seen before. We go, "Oh, this is a Bachyar cluster. Let me explain to you what Bachyar does and how you can use it." And then rather than having to, have them hold a bunch of concepts in their head and try and keep track of where we are in the flow of deploying an application or setting up the network or how connectivity is managed, you can point to these things and say, "Hey, here's how this works," And I've got it here. I can show you it. There we go. I'm gonna have to hold my MacBook up and kind of just pivot it around. But there we go. This is the prototype Expanso football. Right, it's made up of 4 Raspberry Pis, 1, 2, 3, 4, with a bunch of power banks at the end there. When you have a Bachyar network, you have 2 key components. One is an orchestrator node, which manages deploying workloads where you want to do, and the other type is compute nodes. So nodes that execute jobs, workloads on devices that they run. So for this setup, we set one as the orchestrator node. So when someone's interacting with the football, they are communicating directly with that first Pi. And anything they dispatch to that Pi will be distributed out to the other compute nodes here, these Raspberry Pis. So unfortunately, the store I bought the cases in didn't have 4 in the same cases. So I've got 2 Lego ones, which I think will be very handy in the future. And finally, we have this network switch here as well. So this is a Mango. People that aren't familiar with it, it's an open source router which allows you to spin up Wi-Fi networks on the fly, connect to LTE networks, and make sure that everything kind of behaves itself. So you can push a button, turn this thing on, and deploy a workload to any one of these computers. So an AI the Pis themselves, access specific files of data, do some crunching on them, even augment that network with like AWS or Azure, depending on what you want to do with it. And again, we could show people with the Bachyar CLI how easy it was to get this thing going. Now, unfortunately, I can't give you a live demo because, irony of ironies, what country is Raspberry Pi from, Les?
United Kingdom.
The United Kingdom. And so you would think that in a football like this, which is filled with British computers, they'd be powered by a British plug sockets, wouldn't you?
Indeed, yeah, the good 3-pin British plug. Okay,
This is
not.
the new American 3-pin plug, because the power adapters are from the States. So it's a British compute cluster with an American power core. So I can't actually turn the thing on because I've never needed to plug an American thing into a British wall before. But you've got some videos there, you've got some pictures there. I hope this illustrates the idea for people. And if anybody has any questions, then please do let me know. Yes,
we
will
do
be building
actually.
more. Oh, please, Scott.
We do, yeah. Peabody was asking earlier about what are you using to demonstrate the power of this cluster? So you mentioned the Expanso range of software, but if I was Joe Bloggs walking up to your booth, how would you demonstrate the power of that, and what apps would be used to demonstrate it?
So that's a really good question. That's one that we struggle with, because the answer is pretty much anything you can think of. We've worked really hard to make it a super extensive piece of software. The one that tends to get people excited is EdgeML. Edge inference, particularly on Raspberry Pis, because again, they are like super powerful these days. So being able to take like a YOLO or TensorFlow model and just say, hey, I need this to run on 3 Pis, find files in those systems and categorize them for me, or take a video stream from each Pi and, do an analysis and then send them off somewhere else for me to process them later on with perhaps a more capable model on a more capable system. That's something that, is really compelling. But another use case, but again, coming to kind of like things on the edge, is fleet management, be able to configure and manage devices regardless where they are. I don't know about you, Les, but most every Pi project I've ever had in the past at some point has needed to be reconfigured because the network connection has changed, or I have forgotten how to SSH into the system because I use a temporary SSH key. With Bacalhau, I just have that eternal access point wherever I am to be able to do whatever I want with that Raspberry Pi, or any cloud instance at all. The thing to stress here is that it can do pretty much anything on any kind of system. I'm just going to put a link in there for everyone. I don't think they can see that in the chat.
I will put that in the chat now.
Yes, please, thank you. But yeah, so again, EdgeML is one that's very popular. We do a lot of log processing as well. Pretty much anything you can parallelize or anything that you want to do remotely. The thing I find particularly cool about this, and something that we'll be showing a bit more in the future, is that this football could literally be in Australia, and I could still interact with it as if it was sitting next to me. That's the coolest part about it. I wouldn't have to do anything differently. And I could have 1,000 Pis in a briefcase. The next one's going to have way more Pis, So if the Raspberry Pi store people see a man with a big grin on his face walking with a sack over his thing, it's not Santa Claus. This jolly fat man's there for different reasons.
You've actually, that's a question I asked you earlier on about the model of Pi. So you've got Pi 5s, but how much RAM has each Pi got?
So each Pi has 4 gigabytes of RAM, so 4, 8, 12, 16 total in the entire system. That was because that's what they had available at the time, and because for the things we were showing, that it was more than enough. What was it Bill Gates said? You only even need like 512K of RAM. Well, we've got several magnitudes of order more than that. But there is no like maximum like limit to what we could do with that there. What I really want to do in one of these in the future is put a big NVIDIA GPU in that thing to kind of really show off how extensible it is. But I think I will probably go and get one of the bigger Pi 5s for the next iteration. One of the nice things you can do about specifying workloads in the back of your network is say, actually, this is a really memory-intensive application. So find me a node in that network. So find me the Pi that has that capability to run that job, rather than just saying, potluck, which one can do it, which one can't do it. It's like, no, I specifically need these capabilities. Go and do that there. So yeah.
Very cool. Well, also, Ziv Zulan I mentioned before, when all the machines are pooled together, is it like a collective pool of RAM, or does each Pi have its own set amount of RAM and that's all it's got to use?
So yeah, there's no kind of like cross-sharing of RAM across the network at this time. What Bacalhau will do is it will try and figure out which applications require what amount of memory, and it'll figure out what system has that capability or availability at that time. So if you have, 4 Pis in the system as we do here, or we know the computer's there, but one job requires, say, 6 gigabytes of RAM, it's not going to take 4 from one system and 2 from another. But if you can segment your job in such a way that it can offload some of those things, they can certainly help you navigate around that. And who knows, that could be a really great feature that we could explore in the future. This is part of what I do here, is listen to people, the things they're curious about, and answer the questions. And if the answer is no, the next question is, well, why not? And often the follow-up question to that is, how would we do that? How can we do that? It's open source, so people want to contribute that capability, then please do come along and let us know. It'd be great.
Very cool. It also leads me to a question of my own now. I need to just look over to my left-hand side of my collective desk full of everything. So recently, Raspberry Pi released the AI Hat Plus kit. Let's do the YouTube
You have
trick.
no idea. Yeah, you have no idea how close I came to purchasing one of those for this in the Pi store.
That's about 100 quid if memory serves. And 26 tops is the performance. It's a Halo 8.
Powerful.
Yeah, but could you have, for argument's sake, maybe you don't know the answer, maybe you do. Could you have 4 of these on those 4 Pis all working together?
Excellent question. Probably not straight out of the box, but also with a little bit of wrangling, it probably wouldn't be too difficult to do it. So the reason I didn't purchase that in store when I was building this thing was I knew I had very little time to actually experiment, and that is definitely a rabbit hole I would have gone down and probably not finished the thing in time. But the second one was, I'm not too sure about how that device interfaces with the Pi. Like, it is a standard hat, but there is almost a pre-compilation step of models that you want to run to the framework that runs on that chip, as I understand, which is totally something that can be done, but I'm not quite sure of the mechanism yet. So the answer is probably yes, but let me check.
Oh, that's fair enough. Good answer. We've also got, it's not a question, more of a comment, but I do like this comment from Jordan Joe Cooper. I can just picture you at customs, particularly when they ask, what exactly is this?
Wow. That was a question I worked very hard to avoid, which is why because I was initially going to be like, no, if you just go in there confidently, then it's fine, right? If I don't look nervous, then no one else should look nervous. But then it was stressed to me by friends, family, loved ones, colleagues, pretty much everyone I spoke to about this thing. They're like, you should send that through the mail. And so I did send it through the mail. In fact, it arrived literally at 2 p.m. today. And whilst it looks like it's in a good state right now, what's the word I want to use here? It was mullered. It had a thorough going through at some point in transit from California to London. So I spent my afternoon rebuilding this thing, but it all still works. Individually, the components behave themselves. So we will be building more of these, and we will be bringing these more to more conferences in the future. The question now is, how do we make it look like less of an issue when it comes to, because at some point someone's going to have to carry that through a security check and go, it's a computer, but it's several computers that work together.
Yeah, and that links into Jordan's question again about, are you going to make a bigger version?
So we like straight out of the box, there was some like quality of life improvements we wanted to do. Like, we don't like having an external keyboard, so we'd like something that lets us interact with it in a more kind of inline way almost, whether that's a touchscreen, whether that's a fold-out keyboard, we don't know yet. But we also immediately started thinking about capabilities we'd like to see about it. So even though we are now able to point to parts of the network and say, this is going here and this is doing that, we do want to be able to like show things moving around the network, which is not what Backyard is really designed for. It's designed for doing, not showing off. So I want to make it show off. So we'll probably add a couple of unicorn hats to it at the very least, to show what node is executing what job at what time and how it's actually routing to there, and what the current like resource availability of each node is in that network, and then tie that to what the screen's displaying. So that's just like iteration 1. We want to do some real-time vision inference. So we'll probably add a little webcam or Raspberry Pi camera to do some Edge ML on the devices there with cameras, whether that's one camera per Pi or having one camera on one Pi that we can say, oh, this is a vision job, so it needs to go to this one, so go and do that there, please. There remains to be seen. And again, your AI hat is something that we have we've looked at and gone, tasty. So I don't think there'll be one next version that has all those capabilities. I think there are going to be at least 2 other versions which are slightly different flavors. of what they're capable of. And the thing I think really cool is being able to hook them up as well. Again, the whole point of Backlio is it doesn't matter where your nodes are, as long as you can find that orchestrator nodes, they can all communicate with each other. So you could have conferences running simultaneously, or have me down the pub being very professional with a lovely pint of lemonade, and one football, and then my colleagues somewhere else in the world with their briefcase computer doing their things, but having some of that compute offloaded to demonstrate those capabilities. Also switches. The whole point of what Backlio can do is be incredibly resilient to changes in the network. That's one of the things it's kind of designed from the grounds up from. But it's kind of a hard thing to visualize. So we like the idea of bits that you'll be able to take out of the briefcase, walk away with, and see how well they behave, and then how well they resume when they come back. Being able to flip switches, more like a control panel, to say, okay, let's kill this node. That node's gone now. How does the job respond? And start seeing it bounce around the network, finding a place for it to go and be executed. So there's lots of fun things that we can do with it. The company color is a couple of shades of purple, and I really want to kind of channel Johnny Ives in the mid 90s with the original iMac, and try and have that kind of like translucent, delicious bevel sort of purple stuff going on.
Yeah.
But we'll have to see how time and budget allows. I'm sure we'll find both at some point.
That would be very cool. I mean, translucent purple. I'm sure there's a company in Sheffield that have a pirate name, sort of, that could probably help out.
I mean, straight up, I want to put lasers in it. Not for anything other than lasers are cool, but lasers also blind people, so that's probably not going to happen. But I didn't send you the picture because it was taken at 5 a.m. in the morning when I was clearly delirious, having been awake for like 36 hours, which is not a commonplace thing. I want to stress. The company did not make me do this. I was having too much fun. But I did buy LEDs for a jacuzzi. Jacuzzi LEDs. They're on discount in the hardware store. So I got like 16 meters of them for $40. I was like, oh yeah, I could just fill the case with these. And sadly, there wasn't enough time to affix it to the case properly without just being this huge tangled LED mess. But there are definitely ways we can make a yes, quite.
There's more lasers.
Definitely ways to do it. And to be fair, when we were at TechCrunch Disrupt, there were other people who did have lasers. So I'm sure that there's some way to do it safely.
There will be. And lasers are cool, but yes, laser responsibly.
Laser responsibly. Laser in moderation,
Yeah. Tim also mentioned something. I forgot about the video. I did watch it, but it was a while ago, I think. Jeff Geerling did a video on loads of AI cards all linked together on the Pi 5's PCIe connection.
I did see that from Jeff Geerling. I didn't watch the whole video either because I've had a busy couple of weeks. But again, that's kind of what got me thinking about, maybe it'd be possible to put a juicy NVIDIA GPU in there. And, because it kind of feels silly putting something that can do, several multipliers of compute power for those applications to a very small low-cost computer, having this like $800 GPU attached to it. But at the same time, I've taken a compute cluster and I've crammed it into a briefcase. Silly is kind of the theme here a little bit, if only to show it off.
Definitely.
Yeah.
I'm just looking through Jeff's blog now. What was it now? Was it recently?
It was fairly recent, last week and a half, I'd say, yes.
Yeah, he's done something more recent as well. He's got one of the new AMD Radeon Pro W7700s GPUs, one of the workstation cards. And if I remember rightly, he's doing machine learning, LLM, that sort of stuff on AMD cards on a Pi 5, even though AMD says, no, you can't do that. He's doing it through Vulkan, I think.
Ooh, Vulkan is an interesting angle there. One of the nice things about Backlio is it does support GPUs from AMD and NVIDIA out of the box. So it might be a fairly simple thing to do. I'll have to reference Jeff's video and see what the secret sauce is. But if that does behave itself, then maybe I'll have something for you sooner than I realized to show off again, Les. rather than my annual drop-in.
You're always welcome to be on the show, mate. And I'm not saying that for that, that fake presenter thing. Don't worry.
Yeah. Oh, to be fair though, if it goes wrong, I may have a briefcase that catches on fire. So
bring that on as well.
Look, we have to celebrate our failures as well as our successes.
Yep.
Although
failure is how we learn.
Success. Exactly. No magic smoke has come out of this one, which means that I've learned from my many, many mistakes from previous years. Hopefully.
Yeah. Hopefully. Fingers crossed. But all this talk of Jeff Geerling does remind me as well, and we have got a posh video segment for this now.
Ooh.
Which isn't that button. It's this one. There you go.
There we go.
Next week, Jeff Geerling's on the show, and he's talking about external GPUs on a Pi 5 and Doom Eternal, because he plays that, Crisis on a Pi 5, and we may squeeze in a bit of talking about, doing AI stuff on GPUs on a Pi, maybe, but probably talk about Doom for 30 minutes, knowing me.
Nice.
There we go.
That's a good way to spend an evening. I'm going to tune in. I don't know why anyone else wouldn't. That sounds like a great deal of fun.
It'd be fun, yeah. But another way I've been having fun recently. So I do a lot of writing, as you know, a lot of writing I do, seriously. And I haven't done as much hacks recently, but if I saw something that caught my interest. So Blue Sky. Everyone's going to Blue Sky. I've gone to Blue Sky. We're not going to talk about why. It's cool, it's interesting, but I wanted to know what it could do, so I messed around a bit. So I'm going to show you something. It's not a live demo. It's a story that I've written up the other day. And let's just solo it so you can see it a bit easier. How to send and receive Blue Sky posts with a Raspberry Pi Pico W. Yeah, that's $7, $8 little microcontroller. You can do this with an ESP32 or an 8266 if you wish. It works. But I've got a Pico W on the desk. I thought, could I send and receive stuff? Well, initially, I didn't think that. What happened was I got a Raspberry Pi 5 out, I got my Windows PC out, and I started hacking around on Blue Sky to see if I could send and receive. And yes, I could. It's got a Python API. That's pretty easy to work with. That caught the attention of someone on Blue Sky, Mike Bell. And Mike's like, hey, I wonder if I can work with MicroPython. And before I had a chance to really think about what Mike had said, he'd already done a proof of concept where it was reading the skeets, they're called, these messages from Blue Sky in MicroPython on a Pico W. So you could have remote control of Pico W by just sending out a skeet to say LED on, LED off. So I borrowed Mike's code with his permission, and I had a tinker around. So that's the video for it there. I'm going to try to see how this works. You won't be able to hear me. I can hear me right now, but you can't hear me. There we go. And really what I'm doing here is typing in a skeet on Blue Sky saying LED on. I've got some Python code running on a Pico W, and the LED is going to turn on. There you go, as if by cue.
That is very cool. Very cool.
And then in a few seconds later, I type in LED off, and it turns it off. And really, all I'm doing, if you look on the left-hand side of the screen, if I just... Now, come on, Les, be good. There we go. No, stop it. There we go. Professional to the last. There we go. If you look at line 18 on the code on the left-hand side, the while true, the loop is just going around and getting the latest bloot. This language, this API calls it a bloot. Really, it's a skeet, but well, it's just a post. It gets the latest message from my Blue Sky account as JSON. It's just a JSON object. And that's so easy to work with in Python because it's just a dictionary, really. And dictionaries have keys and values. So I just go through the keys and values and say, right, go to the feed, go to position 0, get the post, get the record, get the text. So in other words, get the text from that message. And if it says LED on, so if message is LED on, turn the LED on. If it says off, turn it off. That was it. So that LED is controlled via Blue Sky. But then I thought, what else could I do? So I haven't got a picture of this, unfortunately. I've got it on here. There we go. So I've got a, hopefully you can see this because there you can, there we go.
Yep.
So I've got a DHT11. That's that blue waffly coloured thing there. That's a temperature sensor. And I've got an LED. And what happens now is if I send a message saying temp check on Blue Sky, it goes to the Pico W and goes, right, you said temp check. What you need to do is turn on DHT11, get the latest temperature, format it into a string, put it into a message, and then send it as a skeet via my Blue Sky account. And when it receives a message, it also blinks the LED 3 times to show me it's got an active connection. The power of an LED is impressive. It just lets you know when things work without having to debug anything. And surprisingly, it worked. And I was shocked because my code never usually works. It takes at least 3 or 4 iterations to make it work. But Blue Sky's API is really simple. So there's a whole guide on Tom's Hardware to show you how to build this. And I assure you, it's simple. And if you've got a PCOW lying around, if you haven't, you can use a Pi if you want with the AT Proto Tools Python library. You can use your Windows PC, your Ubuntu laptop, whatever you've got kicking around. And it works, and it's great fun. It's like hacking around with the old Twitter API.
I was just thinking that, like, one thing I've really missed in like the modern web is how much is open to experiment and play with these days.
Yeah,
and it's really nice to see kind of Blue Sky take on that mantle almost of just fun experimentation and openness to try. My code rarely works either, but the times that it does it was very exciting, particularly when I think this is the thing that's really compelling for a lot of people when you can impact something in the real world. It's great having, hello world come up on the screen, but having a light turn on and off through something you just wrote somewhere else, I think it's a different level of magic and excitement right there.
Oh, definitely, yeah. And also Jordan in the chat just mentioned Telegram's API is really good. It is. Telegram's API is really good. The bot master, I think it is, you have to go to create a bot. I did an app of a year or 2 ago where a plant would send me a message on Telegram to say that it needed watering.
Nice. I could do with one of those. My house plants are not having a good time right now.
Well, the guide's on Tom's Hardware, so you can read about it, Sean.
It's where I get all of my plant and technology related news, like hand to God.
Excellent. That's what we're here for. That's awesome. Well, we're coming to the end now, I'm afraid. We're running out of time. I want to say thank you for Sean coming on the show this week. It's always a pleasure, never a chore to have you on.
Likewise, it's always a thank you for having me again. Like, I'm sure one of these days you'll be tired of me, but till then, I really appreciate having me on, Les. It's always an absolute delight to spend time with you.
You make great projects, mate.
Thank you.
They're good fun. They show off what can be done with open source technology. They also show that there can be a little bit of brevity and lightness in this world, which is wonderful.
If that's all I bring, then I will leave it happy.
Thank you. So we are going to be back next week. And yes, it is the infamous Jeff Geerling on the show next week. He's going to be back to talk about GPUs on a Raspberry Pi 5, how you can hack them to make them work. You can play Doom Eternal, Crysis, Super Tux Kart at 120 FPS at 4K. That's impressive. And how you can connect.
You can not afterwards, because that is a tough act to follow right there. Jeff brings the thunder.
Yeah, it's Jeff. He just comes in and goes, here you go, here's some GPUs. He's got 6 displays running on a Pi 5 as well, 2 from the onboard Pi GPU and 4 from that AMD Radeon card.
It's a whole other level. That's crazy.
It's impressive. So I definitely want to be there next week to watch this. I have to be there, so I'll be the one talking.
So you're probably the only person who it's not optional for, but I'm very much looking forward to tuning in.
Brilliant. Cheers, Sean. Well, that's it for this week. Thank you very much for joining us. We'll be back next week at 2 p.m. Eastern, 7 p.m. at UK time. Thanks very much. See you later.
Bye, everyone.